My name is Dean Wells. I work in the Windows Server and Assurance team. I own a technology called Windows Server 2016 Shielded VMs in Hyper-V. This is a technology that allows a virtual machine to protect itself against malicious administrators and also to assert which fabrics it's allowed to run on, all by itself. So if somebody were to steal that virtual machine and try and run it somewhere else, it simply won't be able to power up. If somebody tries to inspect that virtual machine, they cannot see its memory. Its disks are encrypted. Not the same as the way that VMware encrypt the disks. This is done via TPM, i.e. Trusted Platform Module, and boot measurements, and all those good things that we've gotten used to with BitLocker and Windows over the years. All of those things are part and parcel of this solution. So probably not the show where I need to do this, definitely preaching to the choir, but these are the sort of money losses we're seeing now as a result of cybersecurity. So there is definitely something that needs to be done about this. But in the attacks today, we found after years of research that there is a common element. And it may initially seem rather obvious when you see what this boils down to, but it took a while for us to get the statistics to back it. This is what everybody is after. The gentleman before me spoke about the very same thing. People are coming into the network using whatever infiltration technique works for them, and they're then going to go and seek administrative credentials, using things like pass the hash or pass the ticket, or they'll go and replace image binaries by tweaking the registry and making it run something it wasn't supposed to run, a piece of malware. Ultimately, they're trying to get to these significantly privileged credentials. Now, we actually thought about taking these credentials away, eliminating the notion of administrator, completely eliminating it. So there was no such thing as the equivalent of root or supervisor or admin. We thought about that, discussed it for about 4 minutes maybe, laughed and then moved on. We can't do that. It's been in the ecosystem too long, literally decades ago. Decades ago, we handed this out. If you look down here, we've got VMS, Unix, LAN Manager, 3+ Open, 3+ Share. A few of you are old enough in the audience to know what I'm talking about. We can't just pull this back in, so we have to do something else to prevent this misuse of administrative credentials. Now, if you split the misuse up into two halves, we've got attacking the applications and infrastructure. This is all green because we've got lots of companies doing lots of things in lots of ways to protect compromised privileged accounts. We're doing that. There are other companies doing things there. Unpatched vulnerabilities, anti-malware, antivirus, code integrity. It's all over the place. So I'm not saying we've solved this side because it's a game of leapfrog, right? We do something, the attackers do something. We do something, the attackers do something. But this side has been ignored, completely ignored by the entire industry, with the exception of us. Now, what I'm suggesting is a virtualization fabric, whether it's VMware, Citrix Zen, whether it's what Amazon runs on top of whatever that is, whether it's Hyper-V, it doesn't matter. An administrator of that fabric is one step away from being an administrator of every workload that runs on it as a virtual machine. Would anybody disagree? If I run a domain controller on that fabric, is the Hyper-V admin now effectively a domain admin as long as they've got the smarts to know how to enact the attack? That is, I'm afraid to say, the case these days. Shielded virtual machines make that near impossible. We don't necessarily know how to do it without some very specific vectors in mind and physical access to the box. So I was intending on showing you a live demonstration of this attack. However, due to the unbelievable number of people using Wi-Fi and cellular and Ethernet in here, our connection back to our corporate network is useless. So I'm going to use DemoMate. I don't really like using this, but I don't have a choice because I can't get the terminal server session to hang up for long enough. So imagine I am now a Hyper-V administrator. This could be VMware, as I said. It could be Citrix Zen. It could be VirtualBlocks. Any of these virtualization technologies are susceptible to this same attack. I'm going to do it on our stuff so that we don't have to bang the competition quite so hard. But Windows Server 2012 and 12R2, Hyper-V there was susceptible to this attack. Server 2016, not so much. So imagine I'm that Hyper-V admin. I want to steal some secrets from one of the virtual machines running on a fabric I administer. So I log on locally as an admin to the Hyper-V host. I go into the SAN and into my virtual disks folder. I've got VMDKs and VHDs, so obviously this is a hybrid fabric. So I'm using both Windows Server Hyper-V, and I'm also using VMware. I could enact this very attack against the VMDKs, but let's not batter the competition too much. I'll do that later. So instead, what I'm going to do is I'm going to go and do it on the VHDs. So if you look here, you can see I've got a VHD that was cleverly named ADDC1. Well, thank you, person, for telling me exactly what that is. I'm fairly certain that that's a domain controller. So it's a VHDX file. So if I click it, and I then say mount, it mounts it as a disk. Windows presents it as though you've just attached a physical disk to the operating system. Literally that simple. Now, it's still enforcing ACLs. Access control list entries are still being enforced against me because it's Windows, it's a Windows ACL, it's an NTFS file system. But this folder here, does it look familiar to anyone? NTDS? You'd expect the ACL on that folder to say administrators only, right? But I am an administrator on this machine, and that is exactly how it's enforcing the ACL. It said administrators only, I'm an administrator on this machine. So it lets me in. So I go into the NTDS folder, I right-click on the ntds.dit and copy it. I go back up, go into the password dump folder, paste it in there. I then download one of, last count, I think I found 5 tools online that can brute force Active Directory databases in a raw form, and it can take days, weeks, or months, depending on the complexity. But ultimately, it will get passwords, and it will produce a list that looks exactly like this. Now, obviously, my password is not Mary Poppins, as funny as that might seem. That is not my password, but this is the key value pair style of output that one of these particular tools produces. Now, let's say it took it 45 days to get that password out, and that password gave it domain admin. How many of you know in your Active Directory that your policy would allow a password that is now 45 days plus old to still work? Would in my company. Ours is at 60. A lot of our customers are at 120 because of feedback they get from their employees never being able to log on because they can't remember the password after the 4th change. Even if it wasn't a case, there are still service accounts that use this password. So I'm still going to have some leg up by virtue of this attack. And how exactly did I exercise this attack? All I did was go inside, steal the virtual machine's disk, grab an ntds.dit database, I could copy it off onto a USB stick, go running off home, and now nobody is any the wiser that I've got this. How much time do I now have to start hammering on that with brute force software? As much time as I like, because no one knows I've got it. They don't even know I'm doing it. Finally, when it reveals a useful password, that's probably when I enact my real attack, when I'm actually finding what I really want. The credential is just a step in the right direction. Okay, so let's go ahead and flip back into the presentation a second. So take a look at this comparison. If you say bare metal, Hyper-V with shielded VM, on bare metal, a server administrator has access to it. That's a green checkbox because they're supposed to. They're a server administrator. What about a storage admin? That's a green X because they do not have access, and that is supposed to be the case. They are not supposed to have access. They're a storage admin. We can protect things this way. Look at this for a virtual machine. Again, Citrix, Xen, VMware, it doesn't matter. I have access to things that I shouldn't have access to merely because I administer the fabric on top. The workload doesn't know it's even happening to it. Think about it with volume shadows. I could create a volume shadow, a snapshot, on the disk, reach in under the covers, copy off the VHDX from there, and I'm done. Nobody even knows that I copied it off. And I copied off a consistent copy of a VHDX because we used our snapshotting technology in Volume Shadow to make it consistent. We even told the domain controller, make it self-consistent because we have the ability to project that snapshot request into the virtual machine. So Active Directory helpfully went and made the database consistent for the attacker. Thank you, AD. Good job. We're doing it for backup purposes, but it can also be used against us. If you look at that, obviously, with shielded VMs, that's not the case, but I'd rather show you that. So this is what we introduced. This is my dun-dun-dun-dun-dun slide. There was sound with it, but I don't have the audio hooked up. So this is what we introduced. We call it a guarded fabric. Now, what exactly does this do? Well, let me give you the quick run-through. First of all, we invented a brand new synthetic device. We call it a TPM. Clever, huh? So that's a VTPM, a Virtual Trusted Platform Module. It is not bound to the physical TPM in the host. I must emphasize that. It's not bound to the TPM in the host because the VM has to remain mobile. I can't tie it to a TPM in the bare metal host. The VTPM is TPM2 compliant. It was written based on the same microcode as TPM v2 is out there today. So Windows doesn't know it's a VTPM. Windows sees a TPM. Linux sees a TPM. It's just a TPM. At that point, we now have UEFI, secure measured boot with TPM boot measurements. We can now BitLocker that machine Well, we could do that before using a BEC file or some kind of way of delivering the key. But the point is, the key becomes the vulnerability. This is why everybody uses TPMs as their BitLocker key protector. Who knows, quick show of hands, how a TPM releases keys? Okay, he should. He works with me. You're fired if you don't. So the way a TPM releases keys is there's a certain set of measurements. So as an operating system boots, things are being measured using hashes or various other measurement types. And they're entered sequentially into a file called a TCG log, a trustworthy computing group log file. This records a sequence of events and the order in which they occurred. We do that from UEFI up through the OS loader, right the way through to where the kernel loads. The hypervisor's already in present, that's been measured too, right the way to the point where you get a credential provider prompt. At that point, BitLocker knows what those measurements are and says that's healthy. If you turn on BitLocker now, those measurements are recorded inside tiny little registers inside the TPM called PCRs. And we seal the BitLocker key to that exact set of measurements. When you reboot a real machine with a real TPM, or a virtual machine with a VTPM, as long as the boot measurements don't change, when BitLocker says release the key to the TPM evaluates the measurements, and if they're the same, it releases the key. What if you'd added a rootkit? Would the measurements be the same? They would not, because we would be measuring the rootkit as a binary. That would have poisoned 1, 2, or 3 of the PCRs, the registers where we store the measurements. They would now be poisoned. Therefore, the TPM would refuse to release the key. This is now true for virtual machines. We can now do that with a Windows 8 or Windows 2012, a Windows 2012 R2, or a Windows Server 2016 virtual machine, and we'll be releasing Linux shortly. We've got a few more things to do, but we're close to having Linux shielded VMs as well because Microsoft loves Linux. Okay, I forced it out. So, with that in mind, what is the attack vector for a shielded virtual machine? The VTPM, right? So, how do you make sure the VTPM, when the virtual machine is at rest, is protected? Because when the virtual machine isn't running, what is the VTPM at its bare bone minimum? It's a set of bits on disk. So if I can attack that, I'll grant you it's a complex attack and simulate the boot measurements, I can reveal the BitLocker key and decrypt the disk. Okay, that's viable. So how do we thwart that attack? Everything in our fabric has to be measured as healthy. So we have this whole process where you add a new Hyper-V host that has a TPM inside it and can be a guarded host. You have to take an endorsement key from its TPM and give it to a service that we call the host guardian. It's a 3-node cluster that can scale to tens of thousands of Hyper-V hosts. It understands all the endorsement keys of all the blessed hosts. It also records a baseline measurement that is the following. When you booted in a known healthy state because of trustworthy admin in the front row here, you were the trustworthy admin, you said it's healthy now, we'll record its TCG log and add that to an inventory database on the host guardian service that says, yes, that equals healthy. Last but not least, who's heard of Device Guard in Windows 10 or Server 2016? Device Guard? Going once, going twice, you're all fired. Okay, Device Guard, code integrity policy, plus, 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 plus. We had code integrity policy in Windows for a long time, agreed, right? We've had App Locker, we had the predecessor that came before that. This one is different, however. This code integrity policy we call Device Guard is not enforced by the kernel. Shake your head around that one a second. If it's not enforced by the kernel, who the hell is enforcing it? The hypervisor. Every copy of Windows, whether it's client or server, and whether it's running Hyper-V or not, boots a hypervisor first. Device Guard uses the hypervisor to enforce a code integrity policy. Why is that valuable? We can put code integrity policy around drivers, around kernel mode components. It's so strong, if you get it wrong, it will stop Windows from booting because we won't allow the driver to load. Good thing if you get it right, irritating if you get it wrong, which is why it has an audit mode capability as part and parcel of that. That enforcement goes one step further. One of the things that I keep saying shielded VMs protect against is an attack vector that you'll notice not another manufacturer, not another vendor says they defend against, a malicious admin. We are designing this for one reason and one reason alone, to protect against access to those machines when you shouldn't have access to those machines. Either because you're a malicious admin or you're a SAN admin and can copy it off. We even protect against malware. So if I take a new Hyper-V host, let's imagine you're the host, we get your endorsement key, we give it to you. You're the host guardian service. We get your TCG log, that's your boot measurements, we give it to you. And we get your code integrity policy, we give it to you. you now know what she has to look like in order to be given a certificate of health. And we will not allow you to decrypt a VTPM until you've given all that information to the host guardian service and he's returned a health certificate. That is the basic model on which this system works. So let me see if I can show you some of the goals. Take a look at these. Obviously, we want data encrypted. We want it encrypted at rest and in flight. The at rest piece talks about the VHDX on the disk. So let me just pause a second. Remember I mentioned earlier on I was going to do a bit of competitor bashing? Okay, here's the time. So in the VMware encrypted disk solution, VMware keeps the keys. Now, they do a good job of securing them. I'm certainly not picking on that technology. But the keys are not known to the guest operating system. So if somebody manages to add a rootkit to the guest operating system, and they then reboot it as a VMware virtual machine, what will the virtual machine do? The answer is complicated. It will boot with a rootkit. Ours will not. Why not? Because it's BitLockered. It has a trusted platform module inside it, and its keys are sealed to a set of boot measurements. So this level of health that we assert on the host before allowing it to run and decrypt shielded virtual machines is also lent, to some extent, to the guest. We don't measure their health. BitLocker is doing that job for us. It makes sense to let the key release cycle be in the control of the virtual machine so that it can assert when it is not or is in a healthy enough state to release that key. VMware's solution can do nothing in that space. So I would ask you, rather than hear the general sort of rag gossip that VMware has encrypted disks, we have shielded VMs, ask a few pointed questions. What happens if the guest operating system is attacked? What happens if the host operating system is attacked? Do you have any defenses against malware or malicious admins on the host? Do you measure the health of the host operating system before releasing keying material to it? All of these are questions that allow you to learn for yourself. I don't want to sit here and just bamboozle you with all the facts, but we can say yes to all of those because we thought that was the right thing to build. It's not a coincidence. We made sure that these things were in place because it's the only thing that we believe equates to fully secure. All right, so who is this for? As a hoster. Now, you can imagine which hoster I would like to see running shielded VMs. Who would that be? If any of you say Amazon, I'm going to barf. Obviously, Azure. So we're working on getting shielded virtual machines in Azure. It isn't there right now. We have a similar sort of capability to Amazon and to VMware on-prem in that we have an encrypted disk offering, but we want to put the whole kit and caboodle, the shielded VM kit and caboodle, in Azure. But at Azure scale, it literally makes 10,000 Hyper-V hosts look like chump change. That's a data center on a bad day. That's nowhere near enough. So we've got to reinvent some of the underlying mechanisms in shielded VMs, and we're doing that as I speak. Obviously, as a tenant, it's very useful as a tenant for you to be able to say that my data is encrypted at rest, and even when the virtual machine is live migrated, it is encrypted in flight, because we encrypt the live migration traffic. And to make this little story even more complex, but in a good way, the key that is used to encrypt the VTPM and the key that is used to encrypt the live migration traffic abides by a principle called forward secrecy, where we roll that key to a new key at every interaction with the host guardian service. Every single interaction involves give me the old key, decrypt. Give me a new key, re-encrypt. That way, the symmetric key that is used to encrypt the live migration traffic and the VTPM on the disk of the Hyper-V host is always rolling, giving you only a very small window as an attacker to leverage an attack against that key. Obviously, that's a good operating principle. IPsec and other technologies do the same thing. And obviously, it can be used as an enterprise as well in a private cloud scenario. The public cloud, branch office, and compliance. Imagine this one. You want to deploy an Active Directory domain controller at a branch office where you know that it runs under the desk of whoever happens to man the reception area. Does that sound like a good idea? No. So what do customers do? They deploy this thing that we invented called a read-only domain controller. Now, I owned Active Directory in Microsoft for 6 years. I joined just after read-only domain controller was baked, and if I joined a year early, I would have shot it. It is far too complicated, and as such, it's been its downfall. RODCs, read-only domain controllers, for those of you that know them, are deployed in niche scenarios, but they introduce too many incompatibilities by themselves to be something that can be deployed by the masses. So if you want Active Directory in a branch office and RODCs are incompatible, what do? You don't. You rely on a WAN. And when the WAN link goes down, the branch office is like, okay, everybody go home, pens down. That's not viable. Now, what would you do? Deploy a Hyper-V host there. deploy a shielded VM that runs the domain controller. That VM is now encrypted. It is capable of defending itself against physically local attacks to that machine. They run off with the whole unit. I don't care. First of all, the disk on which Hyper-V running was probably BitLockered, because that's good practice. Second, the VHDX itself file system was BitLockered by the guest operating system. So you've got 2 layers of crypto to break through first. If they try and attack the VTPM, they've got to get a symmetric key. That symmetric key was being rolled every single time it interacted with the host guardian service. And it's not a fragile solution because you don't want the host guardian service in the branch office. Don't put that there. Otherwise, you put the keys next to the lock, which would make no sense. Host guardian remains in the head office. So if the WAN goes down now, are they out of luck? No, because once the virtual machine has been powered on, it's already got enough to keep running. The interaction with the host guardian service is only necessary from a Hyper-V host when powering on a new shielded VM or when live migrating another shielded VM. So once you've got it powered up, it is extremely resilient to WAN failure, unlike no solution at all with no local domain controller present. And that's just domain controllers. It works for any workload of your choosing. And obviously compliance is a big deal, and it's capable of doing that too. I'll touch on that in a second. Let me get back to my demo. So what if I tried to attack a shielded virtual machine in the same way? So if I go back into the DIT and secrets, let me just eject this first. Okay, so the first thing we're going to do then is we're going to look at the console connection. Here's that VM that we stole the VHDX from. If I click on this, what do I get? I get a VM console connection. If that session was already logged on, I would get an unlocked, pre-logged on console session to a domain controller. We can say goodbye to your network at that point. You're done. It's toast. History. They own everything, and you may not even know they own it. I've often told people, if you give me access to your AD as a domain admin for about 30 seconds, you will never find me and you will never get rid of me short of tearing it down. Because I will create myself a user beneath a printer. How do you create a user beneath a printer? By using pure LDAP and creating a user under a printer object. And I will give it one permission and one permission only. Reset password on an administrator account. I challenge you, find me now. It's really difficult to get people out of AD, so we have to stop these kind of threats from happening at the fabric layer, which has introduced brand new attack vectors. So obviously I can gain the console connection to a non-shielded VM. What about to DCO2, which is shielded? So we'll click on that and connect. You'll get this error. What we're basically saying here is Hyper-V and various crypto technologies and something called a protected process, which is a special kernel mode type of process. It doesn't permit debuggers to be attached. It doesn't permit memory introspection. It doesn't permit keyboards and synthetic human interface devices like the keyboard or the mouse to be attached. You can't do this. It's not a simple if condition. You are not permitted to attach a console to a shielded virtual machine. So if you deploy a shielded virtual machine and you forget to turn on RDP and you forget to turn off the firewall and you forgot to activate remote PowerShell and WMI, you have cleverly deployed a shielded brick. So be cognizant of this. This is not something where we'll go, oh yeah, we've got this back door. I'm not saying that to criticize the technology. I'm saying that to show you how strong it is. There is no way in unless the owner of the VM ensures that they have one for themselves. There cannot be a backdoor or it isn't worth the salt it's built on. So if I close that down then, and then we minimize the Hyper-V manager, let's go back to Explorer, open up the SAN again, and we'll try and do the same with a VHD here. Obviously, if I'm going to show you what happens when you have a shielded VM's disk and mount that, I'm not going to go into VMDKs because VMware don't have shielding. They have little encrypted disks. Ask them about who's the fabric admin in this role. Are they protecting it from the fabric admin? As you can see, this is something that I've got a bit of an issue with. It drives me nuts when I read the marketing rag articles that compare the two. They're not remotely the same. Go find out for yourself, though. Into the VHDs, then. There's the one that I got earlier. Let's do ADDC2 this time. This is a shielded virtual machine. I click on that, and I get, sorry, there was a problem mounting the file. Okay, well, let's see exactly what's going on. So let's go back up to the top. You'll notice it's got a padlock icon. The padlock indicates Windows recognizes the disk, and it recognizes that this is a BitLocker disk. And it needs a key protector that it can unwrap to release the BitLocker full volume encryption key. So the volume is encrypted with the FVEC, that's a symmetric key, and then we encrypt the FVEC with key protectors. That's how BitLocker works. There's Active Directory key protectors, there's Beck key protectors, and there's the TPM key protector. The only one that's added for this guy is the TPM key protector, which we can't access from the Hyper-V host because we're not supposed to. So I can't even gain access to that disk. Even if I take it home, I can still do absolutely nothing. All right. So what about if I attached a debugger to the Hyper-V host? Anyone here know how to use a debugger? Okay, you know people that do though, right? If you attach a debugger to a VMware host with a VM running an encrypted disk, I don't know this for certain, but I'm relatively positive I can find that key eventually. If you attach a debugger to a Hyper-V host running shielded VMs, when it reboots, which it has to do to get the debugger active, we measure that. That's part of those measurements I mentioned earlier that constitute health. So when the Hyper-V host with a debugger attached to it boots up, you look at its TCG log and you go, no, you've got a debugger attached. You are nothing but not healthy. You'll never release the keying material to even power on a single shielded VM or to decrypt its disk. So we've already given you that demo then. So let's show you the basic security model. This is what it looks like. So we've got a VM here. The key protecting it is here. The admin says power on, so the Hyper-V host needs to power it on. So a little bit of a literature reference here, since I'm British. This is Oliver Twist, so I'm going to put on my Oliver Twist accent for a second. So, hello, Governor, I'm host one. Can I have some keys, please? Can I have some? OK, doesn't matter. Moving along. Right, so now what we've got to do is we've got to have the host guardian service say, slow down a bit, my boy. Let's start by giving you a checkup. If you wouldn't mind coughing for a second, I want to assess your health. So it coughs, and it says, right, OK, so I've coughed, at which point the host guardian goes, yes, now from that single cough, just like your doctors and mine do, I know you are perfectly healthy now. So it sends the certificate of health over to the Hyper-V host. It's not a health certificate for that shielded VM, it's a health certificate for the host, and it lasts for 8 hours. So he finally says, OK, so I'm healthy then, can I have the keys now? At which point, the host guardian releases that key, and it gets absorbed into something we call virtual secure mode. That's part of that thing I mentioned earlier, where all Windows OSs from 10 onwards run a hypervisor. They do so not to run virtual machines alone anymore. They do so for security purposes. Who's heard of this industry principle called virtualization-based security? Think about how it works. IOMMU protects DMA attacks. Then we've got second-level address translation and various other virtualization technologies. We all believe that they are doing enough to protect VM1 from VM2 and from VM3. They are isolating them. So why not use those things for security purposes? That's what VSM is. So the key that was unwrapped to decrypt the VTPM is immediately consumed by VSM. So even if somebody was a network admin and they'd sniffed it off the wire, they had yet another encrypted key that they can't gain access to because they don't possess the keying material. So all of this is disabled for a shielded VM. No connect, no PowerShell direct, remote FX, WMI calls, key value pair exchange is the way of interacting with its registry, guest file copy. All of these things are disabled for shielded virtual machines, leaving an avenue of attack for a malicious admin or even malware that is questionable to say the least. How would the malware even run, given that the TCG log would have measured it or the code integrity policy would prevent it? If the admin tries to delete the code integrity policy, that will change the measurement. And to change the CI policy, they have to reboot and get a new TCG log. As soon as they've done that, they come back up, they're no longer healthy. The attack vectors here are rare, if any, but there are platform-level ones. All right, so here are the takeaways from this, then. You get to protect data against online and offline attacks. Admin conveniences, all of them are disabled. This should be a black box to a Fabric admin. The Host Guardian service, a free role that comes with Windows Server 2016, ensures only known and healthy Hyper-V hosts have keys that can run shielded virtual machines. They enforce which guarded fabrics they can run on. That VM can actually say, I let myself run on that fabric, but no other. That is not a technology that is available on any other platform, forget VMware, but I can literally state which fabrics I'm permitted to run on. I'll leave those for a second because you guys can obviously get a copy of this. This has been a fantastic slide for us. We have had so many companies say, whoa, 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 are you telling me if I run this workload unchanged in a shielded VM, I can meet the payment card industry requirement of DSS 3.1? And we say yes. You can now simply move it from a regular VM to a shielded VM compliant. Now, obviously, that's a huge deal to governments and the finance industry. This is not something we prepared ourselves. We had this prepared for us by an independent third party. That was the end result. All right, so with that said, there are a large number of resources online. There are a large number of videos on YouTube with this British guy that sounds similar to me. He's slightly fatter and chubbier than I am, says I. But there's lots of stuff out there. We can give you a copy of this slide deck, but the simple thing to remember is this aka.ms/privsec will get you every single piece of literature and bootstrap you into the rest of the stuff. So in summary, this is, in our opinion, a one-of-a-kind in market. It is not merely an encrypted VMDK, per the competition. I know I've been bashing them. Sorry, I work for Microsoft. Look, pride. It is not merely that. It is about health. It is about attestation. It is about key release. It is about protecting things using boot measurements. It's about ensuring encryption is strong enough so that malware on a host can't simply walk through it. This is a very, very different solution, and in our opinion, it is unique and certainly first to market. So please, get a proof of concept put together, give it a shot yourselves. That last compliance slide I showed you should be tantalizing enough. Thank you very much for your time. If you've got any questions, I'll walk down here so that we can have a Q&A afterwards. Thanks for watching.